Good morning, all. Now we are going to discuss about the sixth module of EC 405 optical communication. Here we have to discuss about wavelength division multiplexing. I think all of you familiar with the term multiplexing. In previous semesters, you have studied this different types of multiplexing techniques in detail. Um, that is frequency division multiplexing, time division multiplexing, chord division multiplexing, etc. In case of frequency division multiplexing, we know that the total channel bandwidth is splitted into different frequency regions. So that is divided and it is allotted to the individual stations or users. And individual stations or users, each stations uses a particular frequency band allotted to them, and the total frequency band is the frequency band is used on a frequency shared basis. That is actually in frequency division multiplexing. Whereas in time division multiplexing, you know that at the time the total channel is used by a particular station or a user. This channel is shared by the timely basis. That is, at particular instant, one channel is using, and after that, another instant, another station is using. That's why many inputs that are applying to the multiplexer. That multiplexer has one output. So at a particular time, the particular channel is connected to the output. That is actually the multiplexer. Here, the wavelength division multiplexing is shown here. There are different channels before multiplexing, and after that, multiplexing. After multiplexing, by using we get a uh, at a time one particular wavelength is selected, and all these wavelength different wavelength channel with different wavelength are multiplexed and passed through an optical fiber, a single optical fiber or a single communication channel. And in the receiver section is also it is demultiplexed. That is, you can see that actually optical signals of different wavelength, 1300 to 1400 nanometer, can propagate without interfering each other. The scheme of combining a number of wavelengths over a single fiber, that is called a wavelength division multiplexing. You can see in this figure, that is the transmitter. In the transmitting section, there are the different transmitter transmits the signals of the different wavelengths of lambda 1, lambda 2, etc., lambda n. And these different wavelength signals are combining. These signals are combining and creating a number of wavelengths over a single fiber. That is actually the wavelength multiplexer. That is fed to the optical fiber before it is optically amplified, as mentioned in the previous module. After the optical amplification, these signals travel through the optical fiber cable, and before going to the reception, it is again amplified and then fed to the demultiplexer. In the optical demultiplexer, that is, I think you know that multiplexer is a two circuit. That is, it has n inputs and one output. In the transmitter section, you can see that different inputs, many inputs, and that is combined into a single fiber. That is a single output. And in case of demultiplexer, a single input that is comes and that is distributed to the different channels and different sections. That different section follows the different receiver and with different wavelengths. They are demodulating. Before going to the reception or the demodulation process, the signal is demultiplexed into again the different wavelength into different wavelengths. That is actually the wavelength division multiplexing is shown here. The implementation of WDM networks a variety of passive and or active devices that to combine, distribute, amplify optical power at different wavelengths. Each input is generated by a separate optical source with a unique wavelength. An optical multiplexer support light from individual source to the transmitting fiber. At the receiving station, an optical demultiplexer record to separate the different carriers before photo detection of the individual signals. And to prevent spurious signals to enter into receiving channel, the demultiplexer must have narrow spectral operation. So with a sharp wavelength cutoff, okay, and they have the some acceptable limit of crosstalk also. And there are these are the features of the WDM or the wavelength division multiplexing. So the important advantages of the WDMs are mentioned below. The very one is the capacity upgrade, since each wavelet port is independent GPBs. And the next one is transference. Each optical channel can carry any transmission format, the different asynchronous bit rate, analog or digital. Okay. And the wavelength routing is another thing. The use of the wavelength sensitive optical routing devices make it possible to use wavelength as a parameter in designing communication networks and switches. And next one is wavelength switching. Wavelength switching architecture allows the reconfiguration of the optical fiber. Okay.